Okay, so now this is going to be the second section of 6.5. I broke it up into two sections, okay? There's some new rules on this. So some different identities that we're going to have to deal with. So I'm going to talk about first that they're called period. See, and I'm not sure if I'm pronouncing this right. Identities. Okay, and basically it says that the sign of t plus or minus 2 pi is the same thing as sine t. Okay, cosine, we sort of already know this, of t plus 2 pi. It's the same thing as the cosine of t. Now tangent's a little different. Tangent of t plus pi is the same thing as tangent of t. What's nice about this is that means any multiple of this, right? Any multiple of that. So tangent of t plus 2 pi plus 3 pi plus 4 pi, any of those will be the same thing as tangent of t. When you're dealing with sine and cosine, they have to be multiples of 2. So t plus 2 pi, t plus 4 pi, t plus 6 pi, and so forth. Okay? So now we're going to use both rules, all the rules that we've learned so far. So it's really important in trig that everything applies to itself. So the lesson that we did yesterday is the same one that we're going to be dealing with today. I just have a few more new rules to go with it. And you'll find this in the next lesson that we're going to do is the exact same thing. Okay, the problems just get more complicated. So let's look at an example. All right, your problems that we have today is it says, okay, so I want to find sine of t. All right, find sine of t, and it's super important that I pay attention to where, what the sign is going to be. Not this kind of sign, but this kind of sign. Okay, positive or negative. All right, so what we're going to do is I have cosine of t equals the negative 3 over the square root of 10. And I want to know what is sine of t. Okay, what is sine of t? But I want it to be in the second quadrant. So I want it to be between pi over 2 and pi. So if you remember to your unit circle, okay, this is really important. If you remember your unit circle, okay, between 0 and pi over 2, both sine and cosine are positive, all right? Between pi over 2 and pi, okay, the sign changes, okay? That is in the second quadrant, so the x is negative, all right? So that would mean that the cosine is negative. Okay, in the third quadrant, from pi over 2 to 3 pi over 2, both of them are negative. And in the fourth quadrant, the y is negative, so that would be the sine of t. So keep in mind that if we're finding sine of t, it's going to be between pi over 2 and pi. Let's see if we have the cosine of t, comma sine t, right? So this will be a positive value. So no matter what I get here, my answer is going to be positive. I have to write it as positive, okay? So we're going to use our Pythagorean identities to solve this problem, all right? So we want to find out if we know what cosine of t is, what is sine of t. No, I have not asked anything about t. I did not ask what t was. I want to know what the sine of t is. So I'm going to start with this rule, sine squared t plus cosine squared t equals 1. Okay, you remember this is Pythagorean theorem. So we're going to change the cosine squared. So I have sine squared t plus, okay, the negative 3 over the square root of 10 squared equals 1. So that simplifies to sine squared t plus 9/10 equals 1. So sine squared t equals 1/10. Okay, now I know people are going to ask, how'd you go from 9/10 to 1/10? Okay, basic algebra, I subtract 9/10 from both sides. Right? Then to get sine t by itself, I'm going to take the square root of 1 over 10. So my answer then is 1 over the square root of 10. If you choose to rationalize it, it is square root of 10 over 10. Okay? And in this case, I'm not going to care. So whether you rationalize it or not doesn't matter to me in this situation. So there's example 1. Okay. We're going to have 4 examples today, so not nearly as bad as last time. Okay, so the next example is kind of interesting. All right, you have problems on your homework that will ask this question, and I kind of like it. So, example 2, we have the secant of t equals 2.5846. Okay, so 2.5846. So in this, what I want to do is I want you to find the values for the other 5 trig functions. So I want the sine of t, I want the cosine of t, I want the tangent of t, I want the cosecant of t, and I want the cotangent of t. So these, I'm going to find these 5 trig functions. I've given one, there's 6 total, and I'm going to find the 5th. Okay. So we're going to start with the sine of t. Actually, no, we're going to start with the secant of t is 1 over the secant of t is 1 over the cosine of t. So we're actually going to start with that one because the cosine of t is 1 over the secant of t. So we start with there. Okay, always look for where's my easiest place to start. So this is 1 over 2.5846. Okay, I will be using calculators for this. Use your calculators. Always round to the 4th decimal. These are 4 decimal problems. So then this equals 0.3869. Okay. Now that I have that, okay, I'm going to look and see, okay, so what are ways that I can find the rest of these? I know cosine and I know secant, okay? So I don't know sine yet, so we're going to go to sine because that's another one that I can manipulate quite a bit in other situations. Now again, think about the Pythagorean identities. Sine squared plus cosine squared equals 1. Okay, that's really nice because if I know cosine, I can find it. All right, now I'm going to simplify this in a certain way so that you can see it just all on one side. So the sine squared of t is going to equal 1 minus the cosine squared of t. And so the sine of t is going to equal the square root of 1 minus the cosine squared of t. So I'm going to go square root of 1 minus 0.3869 squared. Okay. Again, calculator stuff. And I get 0.9221. Now what's nice about this is once I have those two, I can find the rest of them really easily. Okay, the tangent of t is the sine of t over the cosine of t, which is 0.9221 or 0.3869, which is 2.383. Okay. The cosecant of t is 1 over the sine of t. Right? We know the sine of t is 0.9221. So my answer is 1.084. Right, the very last one, cotangent, is the cosine of t over the sine of t. So that is 0.3869 divided by 0.9221. And that gives me 4.1964. Another way that I can do the cotangent is 1 over the tangent of t. Okay, I made a mistake somewhere. I had all these written down from when I did it on my calculators. There's a mistake, and it's right here. And I'll tell you what I did. I wrote this down as 2.383. When I calculated this one, I calculated as 1 over tangent of t, but I put the decimal place before the 2. So let's fix these so that we can make sure we have them. Give me half a second to figure out my calculator. So first I'm going to check the tangent of t and make sure I did that one right before I do this. So 0.3869. Okay, so that is 2.383. So let's do this 3.3869. 0.9221. Okay, so it's actually, the decimal place is just over 1. So it's 0.41964. Okay, so again, this was calculator error. I apologize for that. I had it all written down, and when I looked at it while I was doing it with you, I noticed that it was wrong. So, okay. All right, next example, number 3. Okay, so number 3, what I want, in this case, is I'm going to give you a value. I'm going to say the sine of t equals 3/5. Okay. I want to know what is the sine of pi minus t, 2 pi minus t, if t t is between 0 and pi over 2. Okay, the sine of 2 pi. So keep in mind that if it's between 0 and pi over 2, the sign is going to be positive. That's why we have that value there. Is what is it going to be? Now you know that okay, I think I've written probably down wrong. So I'm going to fix this because there's something wrong with it. And obviously I was moving too quickly when I was doing this on the board, or when I was doing it when I was creating my notes. Okay, so let's keep this 0 less than t less than pi over 2. Okay, so the problem is the sine of t minus 2 pi. Okay. We know that that is the same thing as the sine of t, which is 3/5. Okay. So again, our rules are periodicity rules. Okay, so and it may be that I forgot to write down another rule. I'm going to check this just really quick. I apologize, I'm very disorganized in this one. So, there was another set of rules, and I think that's why I was looking at the problem and it didn't make sense to me. So we're going to go back to section 6.5. Yep, okay, and that's why. Another set of rules, all right. So these actually don't have names, they're just called other identities. Alright, so write these down. Sine of t is the same thing as the sine of pi minus t. Okay. The cosine of t is the same thing as negative cosine pi minus t. Alright, and the tangent of t same thing as negative tangent pi minus t. Again, write these down. All right, you are going to need, you're not going to need to memorize them, but you will use them. So I apologize, the problem was actually correct the first time, but it didn't look good, it didn't make sense to me because I hadn't gone over those rules with you yet. So these are the rules. Again, the original problem was sine pi minus t. So it is the same thing, it's 3 pi. It's 3/5 because the rule says that sine t is the same thing as sine pi minus t. Alright, so let's look at one more. Okay, example 4. This is the last one today. Okay, cosine, I want to know if the cosine of t equals a negative 2/5, and t is between pi and 3 pi over 2. I want to find tangent of 4 pi minus t. So now to do this is a little tricky, right? I don't know off the top of my head. I can't jump from cosine to tangent. Okay, I can go from cosine to sine. So we're going to leave tangent alone for just a moment, and we're going to I'm going to find sine of t first. Okay, this is a super hard problem. This is about as hard as they'll get because you have to be able to make some leaps here. Okay, so we're going to find sine t first. Now, remember the Pythagorean sine t squared plus cosine squared t equals 1, right? So I have sine squared of t plus negative 2/5 squared equals 1. Sorry, I'm going to go off. So I end up with the sine squared t plus 4 over 25 equals 1. Okay, if I subtract 4 over 25 from both sides, I get sine squared t equals 21 over 25. I take the square root of both sides, and I end up with the sine of t equals the square root of 21 over 5. Okay. Now, this is where the rules come in, right? So I'm between pi and 3 pi over 2. Okay, keep in mind that that is in the third quadrant here. So the sine of t is going to be negative. So even though my answer here is positive, I'm in this quadrant, so I must make it negative. So I have, this is going to be a negative square root of 21 over 5. Now I do need to do some erasing so we can go to the next step. Okay. Now you know, based on our rules, that the tangent of t is the same thing as sine t over cosine t. So I know that sine t is negative square root of 21 over 5, and I know that the cosine of t is negative 2/5. Okay, my 5's cancel out, my negatives cancel out, and I end up with the square root of 21 over 2. Okay, again, my apologies on the problem before this. I don't want to redo the video just because of that one problem. So good luck on your homework.